Hello dear students, good afternoon. This is Khadar handling NEET and JEE classes of E4U. Okay, today we are going to discuss very important topic for the competitive level from the physical chemistry of class 12th is electrochemistry. Okay, first of all just we have to go for content sheet. In that content sheet today in this section we are going to discuss the introduction part of this chapter and what is the electrochemical cell. Next one, in that electrochemical cell generally we are classified into two types, that is called as galvanic or voltaic cell, and second one is electrolytic cell. And what is the point of difference between galvanic and as well as electrolytic cell. Okay, next one, some terminology which is related to electrochemical cell, that is electrode potential. Next one, reference, what type of reference electrode we have to consider and how to calculate cell potential, and electrochemical series, just we have to observe some metals and non-metals which are arranged, and its application, and final NERNST equation and its application. In that, from that NERNST equation we have to calculate electrode potential, its EMF cell, and prediction whether the reaction is spontaneous or non-spontaneous, that is feasible or not. Next one, equilibrium constant and Gibbs free energy. Let us start with here. Now let us start with a topic, that is electrochemistry. Electrochemistry. Now in that electrochemistry, first of all what you are going to do, it is electrochemistry is the one of the branch of physical chemistry which study about the interconversion of electrical and as well as chemical energies. It is a electrochemistry, that means the electrons, that means with respect to electrodes. It is a study which with respect to, it is a branch of physical chemistry which study about interconversion of electrical energy and chemical energy, and chemical energy, electrical energy, how it will be varies, just we have to study here. Generally this electrochemistry which is mainly classified, main we have to study main here, we have to study about electrochemical cell. Electrochemical cell. Electrochemical cell. In that electrochemical cell generally we have to subdivide into two types. One is comes under galvanic, it's also known as here voltaic cell, galvanic or voltaic cell, and second one it is comes under electrolytic cell. Electrolytic cell. This is the very important. Now we are going to discuss first of all now what is electrochemical cell. Generally electrochemical cell we have to this is the energy conversion between chemical energy which is converted into electrical energy, that is known as here electrochemical cell. Generally we have to we are having the two types, galvanic and as well as electrolytic cell. Sir, first of all this electrochemistry which is applicable in what type of reactions, in what type of reaction, dear students? It is applicable for here redox reactions. Redox reactions. Redox, in that redox reaction, what is the redox reaction we have to consider, dear students? The spontaneous. Spontaneous redox reaction or spontaneous, generally we have to consider reaction. Already we studied in the previous lectures what is meant by redox reaction. Just of all we have to take it, this is redox reaction. Redox reaction generally we have to consider this in the same reaction both oxidation and as well as reduction takes place. Both oxidation and reduction takes place simultaneously in a chemical reaction is known as here reduction. Already we know oxidation, just I am giving the brief this one. In oxidation, first of all what is meant by oxidation here? Loss of electrons. What, my dear students? Loss of electrons. Come to the here reduction. What is, dear students? Reduction means gain of electrons. Next one here, increase in oxidation number, it is known as here oxidation. Next one here, decrease in oxidation number, it is known as here reduction. For example, if you take any type of reactions, generally for particular reactions, it is comes under here redox reaction. For example, if you take small reaction, now 2H2 plus O2 which gives rise to 2H2O. Okay, just whether it is comes under redox or not, in that redox reaction only here chemical, okay, we are going to discuss, okay, what is electrochemical cell and different types of cells we are discussing. Now, okay, if you check the oxidation state of here, hydrogen becomes here 0, here because it is elementary form 0, here hydrogen oxidation state is +1. What about here? Oxygen is -2. Now, just have check it here, hydrogen from 0 to +1, what happened here students? Increase in oxidation number or not? Increase oxidation number called as here generally oxidation. Next one, if you compare here, oxygen from 0 to -2, 0 to here 0 to +1, here dear students 0 to -2, 0 to -2, that means here reduction, decrease in oxidation number called as here reduction. Both oxidation and reduction takes place simultaneously in the same reaction is known as here redox reaction. Now this electrochemistry we are going to discuss in okay, what type of reaction students? In redox reaction. What type of redox here? Spontaneous reactions. Okay, spontaneous means without having any external conditions, the reaction itself happening, that is known as here spontaneous reaction. Okay, next one, let us start with here. Okay, redox reaction we got it, what is oxidation, what is reduction. Now let me start with here, what is the types of the cell. In that types of the cell, first of all I am going to start with here, okay. Now electrochemical cell, electrochemical, okay, cell. In that electrochemical cell, what is the main I am going to discuss here dear students? In that electrochemical cell I am going to discuss first of all electrolytic cell. First of all you need to understand, because you studied this one in previous classes, because if you understand here the point of difference with these two, then you will not get confused, because okay, here representation both are different. Here what is the point of difference I am going to discuss. Electrolytic cell, in this electrolytic cell generally the electrical energy is converted into chemical energy. Very very important dear students, I am giving the point of difference, chemical energy. This is very very important point here. Electrical energy is converted into chemical energy, and what type of reactions will take place are here. This is the point number 1, I am writing here point number 2. Okay, now here non-spontaneous reactions. Non-spontaneous reaction, whenever the non-spontaneous reaction is there, then we can tell here delta G value which is greater than 0. If the delta G value greater than 0, then I can write here del G value becomes positive. Whenever the del G value change in Gibbs free energy value becomes positive, then it is comes under non-spontaneous reaction. Non-spontaneous reaction. Okay, next one, representation. Okay, now already we know the electrodes. Electrodes, what type of electrodes? If you take it any cell, either galvanic cell or electrolytic cell or anything, okay, we are having the two types of electrodes. One is comes under anode and second one is comes under cathode. This is a very important dear students. Okay, now representation. Anode is there sir, then how we have to represent here? Okay, now I can take it here anode. Anode always, what is takes place here? Oxidation will takes place. What will take place dear students? Oxidation, and its representation becomes here positive. Very 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 important. Okay, now don't get confused. Anode, oxidation takes place here, its representation becomes dear students positive. Next one comes under here cathode. Okay, cathode, okay, what is takes place here? Reduction takes place. Reduction takes place, its representation is negative. Its representation dear students negative. This is okay, anode and as well as what my dear students cathode. Next one here, there is no salt bridge is required. No salt bridge is required. Now I will take it here. Okay, with electrolytic cell, how we have to draw and what are the how electrical energy is converted into chemical energy. Let me start here. Okay, no salt bridge is required. Okay, now if you take okay, now here is only okay same here what you are taking same electrodes you are considering in okay same electrodes in same electrolytic solution. Electrolytic solution. You are not taking here different electrodes and as well as different electrolytic solution, because if you understand this one, you can easily understand galvanic cell, because okay, many students are having the getting confusion with sir how to represent electrolytic cell and the galvanic cell. That's why I am giving the entire okay characteristics of this one. Okay, if you take it this one, just okay, now just I am taking here some electrolytic solution here. Electrolytic solution. This electrolytic solution, just I am putting here two electrodes. I am taking here inert electrodes. I am taking. I can consider this is a platinum electrode. Here also these are the students here. Platinum electrodes I am taking. Then the two electrodes, one of the act as a okay different types of electrodes. Now I can consider this is, I can connect with okay. Now this is, I can consider this is anode. Anode, how to represent, dear students, here? Very good, positive sign here. Positive. Next one I can consider this is, dear students, cathode. Cathode representation is negative. Now I am connecting with okay, two wires in okay, one battery. Now positive means here we can consider the sign should be, this is positive and which is connecting with negative battery, that is called as here negative terminal, that is called as here cathode. Okay, understand? Okay, next one here the sign already we know, this is positive, 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 here positive, positive. Here what is the sign is generating? Here negative, here negative, here negative, here negative. Okay, already we know at anode what will take place, dear students, here oxidation takes place here. Next one at cathode what will take place, dear students? Reduction takes place here. Understand? Okay, now let me take an example here. Okay, let me take an example. Okay, now if you take it here NaCl, that NaCl I can consider this is molten state. I am not taking this is aqueous. If you take the aqueous solution, even water also we have to consider. Now I am not taking this is aqueous, just I am considering this is molten NaCl. Okay, this molten NaCl, okay, generally how it will be dissociates Na plus and as well as Cl minus. I am writing the reactions at electrodes. Okay, now okay, reaction at electrodes I can consider this is first at anode. At anode. Anode just I am representing here. At anode what is takes place, dear students? Oxidation takes place or not? Very good, oxidation, and representation sign is positive. Very important, try to understand here. Okay, at anode that is called as here positive. Positive here what type of ions will come and attract? Negative ions or not? Very good. What is the negative here? Negative ion, that is anion Cl minus, that Cl minus to be converted into Cl2. Okay, only one chlorine atom is there. I can consider this half Cl2 and okay, liberate one electron. Liberate one electron. Is it balance or not? Here minus one charge, here minus one. One chlorine atom. Here what is the? It is in the form of gas. Here Cl minus if we can consider here aqueous. Now Cl minus will be attracting towards in the form of what is here? Chlorine gas will be liberated. Chlorine gas will be liberated at anode. Okay, next one comes under here at cathode. Cathode generally representation, dear students, okay, reduction takes place and its sign representation is negative. Okay, now negative at the negative electrode, what ions will come and attract? Positive. Among Na plus and Cl minus, who is the positive? Na plus. Now this Na plus, okay, will be okay attracting one electron. Okay, it forms here sodium in what form, dear students? Solid. It is, you can take it here molten state, here aqueous. That means the sodium will be deposited at what electrode? Very important here. Sodium will be deposited at cathode. Sodium will be deposited at cathode. If you want to write here general, okay, now how to write the reactions? Okay, take it here Cl minus, if you take it here Cl minus I am taking left side. Next one plus Na plus this electron will be cancelled, gives rise to what you have to write, dear students? Half Cl2 plus Na. Half Cl2 plus Na. I can write in the bracket here NaCl. This type of okay reaction will be taking place at okay at overall reaction. This is at anode and this is at what, my dear students? Cathode. Anode oxidation takes place, her representation is positive. Here okay, at cathode reduction takes place, its representation, dear students, negative. Don't get confused regarding electrolytic cell and as well as galvanic cell. This is the representation. Okay, this is the total cell reactions. Next one, how to represent representation of this electrolytic cell. Understood, dear students? Okay, representation. Okay, already we know left side I am taking always here anode electrode, I am taking anode electrode. Okay, what is the charge, dear students? Here anode means positive. Okay, then comma, I can take it here anode. What will form? Anode product will form. Anode product. Okay, now in between, anode means positive I wrote. In between I can write it here like this, two vertical lines. That vertical lines which can indicates here the medium. What is the medium you are taking, dear students? Electrolyte is we are taking. Okay, then what about the right side you are writing? Okay, anode over. Next one I can write here. Okay, cathode. Cathode is, what is the sign? Okay, negative sign here, and what will form, dear students, here? Okay, cathode product. Cathode product. Understood? Comma, like this we have to. This is the representation of electrolytic cell. Very important, dear students. Okay, anode electrode, that is representation is positive, and I can write it here. Oxidation takes place here. Oxidation, and you can take it. This is reduction takes place here. Okay, anode electrode comma anode product. Okay, next one which is indicated with two vertical line, well, that is medium. What you are taking? Electrolyte. Next cathode product, here representation is cathode, here minus. This is called as here representation of electrolytic cell. Okay, next one here, did I use any type of salt bridge, dear students? No salt bridge, because the same electrolytes you are taking in the same electrolytic solution. That's why we no need to use here salt bridge. Okay, this is a very important in electrolytic in electrochemical cell, that is electrolytic cell. Next comes under here second one, that is called as galvanic cell. Very important, galvanic cell. First of all, what is galvanic cell? How the energy will be conversion? It is the conversion of chemical energy is converted here. Electrical energy is converted into chemical energy. Here, dear students, chemical energy is converted into here electrical energy. Chemical energy is converted into electrical energy. This is the very important, this one. Okay, let me start with here galvanic cell. Okay, how to represent? Here also the same we are going to consider. Now let me take it here. How to represent the galvanic cell, and what is anode, what is cathode, everything we can start now. Okay, now let me start. Okay, now two electrodes I am taking. Okay, this is the two electrodes I am taking, dear students. Okay, now in the two electrodes I am taking some solution. What type of electrolytes we are using? Just I'll explain. I can take it. This is a zinc sulfate solution I am taking. This is copper sulfate solution I am taking. In the two, just I am adding here. This is zinc electrode, and this is I am adding here copper electrode. Here zinc electrode is act as here anode. Okay, next one, here copper which is act as here cathode. Understand? Here sign representation is very important. Here sign representation. Okay, now here anode is there in a galvanic cell. We have to represent here with a negative sign, negative terminal. Next one, cathode is there. You can represent here positive terminal here. Just I am connecting with these two electrodes into the two. Here negative, no, negative means here small one, and which is this one. Am I correct or not? Okay, this is I can represent here. This is the negative and this is the positive terminals of the battery. Okay, next one, in between I am taking here one U2 vertical and inert electrodes I am taking. In that electrolytes just I am filling with some inert electrolytes. Okay, first of all it is called as, dear students, salt bridge. Salt bridge. Okay, now let me start here. How the electrons, okay, you might have been studied in physics, electricity chapter. Okay, electrons flow, next one as well as here ions. Okay, now current flow from, okay, I can take it here, current flow, this is from positive terminal to negative terminal, this is the current flow. Next one if you take it here, okay, electrons flowing here, the flow of electrons, this is flow of electrons from negative terminal to positive terminal. This is very, very important, dear students. Okay, now current flow, it is a positive terminal to negative, whereas flow of electrons, it is quite opposite of okay, current flow, negative terminal to positive terminal. This is salt bridge. Now this is the experimental setup. Okay, now here at anode what will take place, dear students, here? Okay, at anode the same thing, just I am giving the shortcut here. Okay, L O A and as well as here N. Next one I can take it here R C and as well as P. Okay, at the left side, okay, what is there? Lone and RR CP. How we have to indicate, sir? Okay, now let me, if you take this one, L stands for here left side, L stands for left, O stands for here oxidation, and A stands for anode, its representation is negative. Understood? Okay, next one, this is comes under, okay, next one, this is R stands for here right side. What will take place, dear students? Reduction takes place, and C stands for cathode, and P stands for here positive. Just you have to remember, okay, you have to, okay, look at here, just you have to come here previous electrolytic cell. Here anode is represented with positive, whereas cathode is represented with negative. But in case of here galvanic cell, okay, now anode is represented with here, what is the sign, dear students? Negative sign. But in case of cathode is represented with positive. So that means everything is left side oxidation. Now at the anode oxidation takes place here cathode, okay, reduction takes place. Zinc sulfate solution I consider, and here copper sulfate solution I consider. Okay, now let me start with how the reactions will take place. I can take it here at anode. At anode what will take place? Oxidation. Just I am writing here. Okay, now here zinc sulfate, many Zn2 plus ion and SO4 2 minus, Zn2 plus ions, here also Zn2 plus ions. Here what type of ions will be, dear students? Cu2 plus, SO4 2 minus, okay, Cu2 plus SO4 2 minus ions is there. Now at here anode always oxidation takes place, because already given the shortcut here. Okay, not anode, how it will be converted? Zinc electrode is act as anode. Zinc, okay, initially it is a solid, okay, gives rise to Zn2 plus 2 electrons. Zn2 plus 2 electrons. So oxidation, sir, generally if you take it here, oxidation number of zinc here 0, 2 plus 2, 0 to plus 2, increase in oxidation number called as here, okay, that is called as here oxidation. Next one, at anode, at cathode, how the reaction will take place, sir, here at cathode. At cathode if you come here, this Cu2 plus, okay, these 2 electrons will be gained. Already this zinc metal released 2 electrons through oxidation. Now these 2 electrons are absorbed by Cu2 plus ions. It will, now you can take it, this is aqueous, okay, to form here copper solid. Okay, if you want to take the net reaction here, overall reaction I am taking, the overall reaction if you take it here, okay, left side what is the students here? Zn in solid plus right side, okay, left side is Cu2 plus, it is aqueous medium, gives rise to, okay, right side what is there? Here these 2 electrons, here these 2 electrons will be cancelled. Next one, Zn2 plus, it is in aqueous medium plus, okay, here right side copper at solid state. This is the overall reaction, okay, overall reaction of, okay, galvanic cell. Understood, dear students? Okay, this is a practical, okay, what is the experimental setup. Next, I did not okay, explain about salt bridge. Now I can continue on this one. Okay, this is the left side LOA and lone, left side oxidation anode, negative charge, Next one, RRCP, right side reduction takes place, cathode and positive. At anode, what is the reaction? I wrote cathode. Okay, then I wrote here finally overall reaction. Left side I combine, here 2 electrons cancel finally. Okay, please note down situation, we can continue. Okay, next we can continue our lecture. Okay, we already discussed with respect to electrolytic cell and galvanic cell. Okay, in that galvanic cell just we use there, okay, that is called as here salt bridge. Salt bridge and its functions. Salt bridge and its functions. This is also very important, dear students. Okay, now generally if you take it this one, okay, now like this we have discussed now. Okay, now in that what is okay, it is U2. Okay, U2 invertly arranged in different types of electrolytic solution. Whenever the two different electrodes and containing the two different electrolytic solution, then we can use here, okay, salt bridge. But in case of electrolytic cell, we didn't use any type of okay, salt bridge, because we are considering the same electrode and the same electrolytic solution. Okay, first of all this is okay, which is filled with salt bridge, which is filled with some inert electrolytes such as agar-agar jelly, okay, or we can take it here, come KCl, you can take it here, KNO3 and ammonium nitrate and so on etc. we can take it here. Sir, with the help of this okay, salt bridge, what will happen here? This okay, it will, if we use salt bridge, then what will happen here? The movement of ions will be taking place in the correct. Okay, that means here, okay, now if you use the salt bridge, then only the circuit will be completed. If you are not using the salt bridge, the circuit, okay, the circuit will not be completed, then flow of ions will take place here. The very important point here, the salt bridge is act as a just like a catalyst, and whatever the ions is present inside the salt bridge, which is filled with the inert electrolytes, these inert electrolytes okay, doesn't involve any chemical change, doesn't involve in any chemical change. This is the very important point, dear students. That's why simply it is act as like a catalyst. Okay, sir, what will happen, sir? It will be maintaining the okay, now flow of ions, okay, how much? The speed of the cations, which is equal to the speed of the anions. Okay, doesn't involve any chemical change. Next one, what is its function, sir? Why we have to write this one salt bridge? First, a very very important point here, okay, to be maintained electrical neutrality, to be maintained electrical neutrality. This is the very very important, electrical neutrality. That means how many ions flow from anode to cathode, and as well as from cathode to anode, everything will be you have to maintain the same number. For example, 5 electrons lost here, the same 5 electrons will be gained from anode. This is some very important terms we have to study. This is the functions of this salt bridge. Understood, dear students? Next one, how to represent this in galvanic cell, how to represent a cell. Then I can take it here, cell representation. Okay, now if you take generally how we have to represent a particular cell. Okay, now we consider before reactions, dear students. Okay, Cu plus Cu, how we are consider zinc, which is converted into Zn2 plus 2 electrons at anode takes place here. Cu2 plus 2 electrons gives rise to Cu, correct or not? Now how the net reaction is taking place? Zn plus Cu2 plus, this is solid, this is aqueous, gives rise to Zn2 plus it aqueous plus Cu, it is solid. Now how to represent here, dear students? Okay, now I can write here zinc, I can write here zinc. Next one, it is solid, I can mention solid, comma. Okay, next one, we can take it what type of solution, dear students? Here Zn, to oxidation left hand side, Zn2 plus. In the main well we have to represent with one vertical line, and both are separated by this is called as a two vertical lines, only one vertical line which is separated oxidation here, zinc to Zn2 plus. Okay, next one here Cu2 plus, I can take it, this is a aqueous, Cu, it is solid. Okay, now both are separated by salt bridge. This is the way we have to represent cell representation of the particular compound. Okay, dear students. Okay, next one comes under very very important, that is called as electrode potential. That is known as, dear students, electrode potential. Okay, now generally how we have to discuss define electrode potential. This electrode potential which can define here, the potential which developed, the metal strips, metal electrodes versus we can take it this one, metal electrode versus electrolytic solution. This is the we have to study. This is electrode potential. Generally this electrode potential, now before we can take it, this is electrode potential. Next one which is comes under standard electrode potential. Generally this electrode potential we can represent with respect to here, generally can take it RP, reduction potential or electrode potential. Next, standard electrode potential, generally how to represent here, the same, the potential which developed between the now metal electrode versus electrolytic solution. Standard, whenever the standard condition is there, then what you have to consider the concentration, and what you have to consider the pressure, and what about temperature. This is the very very important thing, dear students. Okay, now if you take it, this concentration to be consider, understood, 1 molar. Next one, pressure we have to consider 1 bar pressure. Next one, temperature at 25 degrees Celsius, it's also known as here 298 kelvins. Now the potential which developed between the metal electrodes and electrolytic solution at these conditions, concentration 1 molar, pressure 1 bar, and temperature 25 degrees Celsius or 298 kelvins, such type of electrode potential is known as standard electrode potential. Very very important, standard electrode potential. Generally standard electrode potential we can represent here E0. E0 we can represent here, E0 RP or E0 SRP also we can represent. This is called as standard electrode potential. Sir, how we have to measure a particular electrode? Is any separate reference is there, sir? Yes, the reference electrode is there. That's why first of all we have to consider a reference electrode. Now generally reference electrode I can consider this is the standard hydrogen electrode potential, SHE I am taking. Standard hydrogen electrode potential. This is we have to consider as a reference reference electrode. Now how? Just I am taking this one. Just we have to in this one take this one. In that particular here you can consider here one platinum black. This is called as, dear students, platinum black. Now in that platinum black just you have to this is wire. Next I have to the filled with some some electrolytic here solution. Now I can consider just I am passing here hydrogen gas at 1 bar pressure. Just you have to consider this is water molecules. Water is there aqueous, then after it absorbing the 1H plus it is comes under H3O plus. This is, dear students, aqueous. Understood? Now this is a generally representation of this one. Here what type of at this reference electrode, how the reaction will take place at anode and how the reaction will take place at cathode. This is the based on this only we have to calculate reduction potential. I can take this one at anode. What will take place, dear students? Oxidation. Now how the oxidation will take place here? Then H2 which gives rise to 2H plus. Correct or not? Here 0 oxidation state here. Here what is the oxidation state, dear students? +1 plus. Now if you want to balance here I can take it here 2 electrons. This is the reaction at anode. Check it here, balance are not 2 hydrogens, 2 plus here 2 minus both are cancel. Next one here can take at cathode. Cathode, what is the sign represented here? Anode is negative. Here what is the, dear students? Positive. What will take place here? Reduction will take place. Understood? Now what will take now 2H plus which is absorbing gaining 2 electrons and forming here hydrogen gas. This is the oxidation state, dear students. +1 here 0. +1 to 0 decrease in oxidation number called as reduction. Understand? Now I can take it here the standard electrode potential of here H plus H2 gas which is equal to here generally you can consider standard reduction potential. Generally this SOP, that is called as a standard oxidation potential, which is equal to the negative sign of standard reduction potential. This value for standard hydrogen electrode is equal to what, my dear students? 0. That means the standard reduction potential values for the hydrogen gas is equal to 0 at all temperatures. This is the very important here. At all temperatures. That means what did you understand? When standard oxidation potential which is negative of the standard reduction potential. That point alone you have to remember, dear students. This is the way we have to study. Standard oxidation potential which is negative of standard reduction potential. Next one comes under here. Sir, what is meant by electrochemical series? Now in that standard we are having two types we can study later. Now we can take it here. What is electrochemical series? Electrochemical series already we studied in previous classes also. What is electrochemical students here? The arrangement of different elements. You can take it here. The arrangement of different elements according to increasing order of their standard reduction potential. Very, very important this is. Electrochemical series is generally defined as the arrangement of different elements, okay, according to increasing order of their standard reduction potential is known as here electrochemical series. Based on this electrochemical series only, we have to identify which element is highest reduction potential and which element has lower, okay, which one has a lower reduction potential or highest oxidation potential, like that we have to consider. Okay, now based on this one, okay, if you check it here, small points, okay, note the small point we have to remember. Okay, whenever the most negative, okay, standard reduction potential value, the most negative standard or E naught value, okay, reduction potential which are having the, okay, greater reducing agent or strong reducing agents. Please don't forget, dear students, when a most negative standard electrode potential values, which element which having the greater or strong reducing agent. And one more point here, whenever if you consider the most positive, okay, standard reduction potential which is having the, okay, the stronger or greater oxidizing agent, very, very important this is. Okay, now these 2 points you must remember. Whenever we are having the greater negative SRP, greater reducing character, whenever having the most positive SRP values, having a greater oxidizing agents. Okay, now if you take it this one, okay, the lithium, okay, lithium has, okay, approximately minus 3.05 volt, okay, of SRP value here. Okay, that means here, okay, strong reducing agent, but in case of, if you take it here, F2 fluorine, which is having the approximately value plus 2.85 volt, is there, that means here most positive, okay, SRP value, that is comes under here strong oxidizing agent. Very, very, very important. Based on that only we have to study here electrochemical series. Okay, we have to arrange according to increasing order of their, okay, standard reduction potential, that is called as ECS. From that only we have to write. Okay, next one, what is the applications of this, okay, electrochemical, okay, applications of ECS. In that electrochemical series, what we are going to apply here. Okay, now for example, two different reactions are there. Okay, let me consider. Okay, metal will be displacing. You studied in lower classes. Okay, when copper, which is, okay, react with, okay, silver nitrate gives rise to here Cu. Okay, for example, it is solid. I am taking, this is the aqueous medium. Okay, now what is the reaction will come, dear students? CuNO3 taken twice, this is aqueous, copper nitrate plus 2 Ag, it is solid. Okay, just we compare here the copper and as well as, okay, silver, copper which is having the greater reduction potential when compared to silver, that's why copper will be displaced, okay, silver from its aqueous solution of AgNO3, that is the reaction will takes place like this. But I will take the reaction will be like this. Okay, Ag plus, okay, CuNO3 taken twice. Will it takes place the reaction, dear students? When silver displaces copper, no, because it has a rest, okay, reduction potential and less reactive when compared to copper. That's why, okay, reaction will takes place. No reaction. Very, very important. Because of how I observed here, based on this electrochemical series values is given in the NCERT textbook. Okay, everything we have to study. Okay, this is next one. If you take the metal, how the metal will be replacing here non-metals are. Okay, now if you take one more example, when zinc, which is react with, okay, ZnSO4, zinc sulfate, then how we have to, I can take it here, this one, okay, this is solid, I can take it, this is dilute or aqueous, I am taking ZnSO4 zinc sulfate, that is aqueous and liberates hydrogen gas, but in case of, if I take it this one, when Cu copper which is react with, okay, sulfuric acid, that is also called as a dilute. Okay, this is also solid, this is a aqueous or dilute, then will the reaction will take place, dear students? Here copper is displaces hydrogen, no, that's why no reaction takes. That's due to, since okay, copper is less reactive when compared to hydrogen, so copper doesn't replace hydrogen from its solution, so the reaction never occur. This is about, dear students, electrochemical okay series applications. Next one, okay, one more is there, that is how to write here, okay, cell potential. Okay, generally what is meant by cell potential, dear students? Cell potential, you already studied, okay, this is electrode potential. Electrode potential means the potential which developed between the metal electrode versus electrolytic solution. But in case of a cell potential, how to define? Okay, the potential difference between the two electrodes, okay, present in the solution, that is called as here cell potential. Generally cell potential we can represent, dear students, E naught, okay, E cell. If you are taking the standard condition, that when we can represent here E naught cell. This is without standard condition, this is comes under, dear students, okay, E naught cell, that is the standard form. Then we can take it here, the E naught cell is equal to, okay, E naught cell is equal to, then how to write, dear students, E naught of, okay, cathode minus E naught of, okay, anode. This is the, okay, very important representation of E naught cell. Okay, now from that, okay, just we have to continue. Please note down, dear students. Okay, dear students, next we can continue here. Okay, cell potential. Okay, generally we can represent here E cell or E naught cell we can represent here. Okay, what I said, dear student, just we can continue here. The cell potential, that means the potential difference between the two electrodes is called as here cell potential. Already we written there. Okay, E cell, if you, okay, just E cell, if you take it, this is the normal condition. If you take it here, E naught cell, that is comes under, okay, standard condition. Then this E naught cell is equal to, generally how to write, dear students, E naught of cathode minus E naught of anode. Generally I am taking this one. Generally if you can take it here, E naught cell is equal to the standard reduction potential of cathode, standard reduction potential of cathode minus okay, standard reduction potential of okay, anode. Standard reduction potential of anode. We already discussed there, okay, when standard oxidation potential is equal to the negative of standard reduction potential. Both are, because oxidation and as well as reduction both are reverse. Oxidation, okay, lose of electrons, whereas reduction, gain of electrons. Okay, now what will happen, dear students? I can take it here, E naught cell is equal to okay, standard reduction potential of this cathode minus, I can take it in place of SRP, I can take it here SOP, that means here minus will be a minus of minus here, plus you can take it as standard oxidation potential of anode. Standard oxidation potential of anode. Next one I can write like this also, E naught cell is equal to okay, standard oxidation potential of okay, anode minus okay, standard oxidation potential of okay, cathode. Then we can take it here. This is one of the neat question, dear students. Okay, they given in the okay, which of the following is okay, we have to calculate cell potential. They given the different options here. Okay, this is the way we can do it here. Simple, you no need to get confused here. Okay, because okay, it is a standard reduction potential of cathode minus standard reduction potential of anode. What I wrote here same like this, because okay, cathode okay, reduction only takes place here, and at anode oxidation. From there, what to do it here? SRP of cathode here minus SRP, that means here I can take it this one minus of minus plus SOP of anode. Then we can take it here, E naught cell is equal to standard oxidation potential of anode minus standard oxidation potential of cathode. Okay, this is the way also we can do it here. Okay, now this is called as here cell potential. Okay, now if you take it here different examples how to do it. Okay, now I will take it here, when zinc plus Cu2 plus, it is I am taking here aqueous, this solid gives rise to Zn2 plus, I am taking this is aqueous plus copper at solid. Okay, now okay, how to write this one, E naught cell already we know. Okay, E naught cell, E cathode minus E anode, already okay, we studied here at anode how to represent, dear students, here at anode. Okay, oxidation only takes place, no oxidation, representation is negative, that means I can take it here, Zn gives rise to Zn2 plus plus 2 electrons. Next one at cathode, what will take place, same thing I am writing, okay, because okay, different, this is representation is very important, that comes under here plus, that is positive, that means here reduction okay, Cu2 plus, it will absorbing the 2 electrons here, gives rise to Cu, it is solid. If you take it this one, which one? Then I can write it here, the E naught cell is equal to E naught of cathode, which is the cathode, dear students, this one or not. Okay, you can take it here, E naught of okay, how it will be, Cu2 plus 2 Cu minus okay, E naught of anode. What is the E naught, dear students, anode? Okay, Zn becomes Zn2 plus. This is the way we can represent okay, E naught cell of the particular reactions. Okay, you can take it in a different reactions also you can take it. This is called as what, my dear students, cell potential. Okay, next one comes under here. Okay, now what is okay, cell potential you understood now, what is reduction potential, what is standard reduction potential, you got it here. Next one, how to calculate E naught cell, we can calculate. Okay, next one very important, that is called as here okay, NERNST equation. This is only very important. NERNST equation. Sir, what will give the information about this NERNST infection? Okay, NERNST equation, sir. Okay, it is giving the information about E naught cell. Okay, that is the standard reduction potential versus the concentration of the okay, electrolytic solution or concentration of the electrolytes. Okay, that is next one. This okay, NERNST, which is derived his expression, which is based on okay, that Gibbs free energy, that is called as here del G is equal to del G naught plus RT ln cube. Okay, now it's giving the relation between Gibbs free energy versus okay, reaction quotient. Here del G, which indicates here okay, Gibbs free energy, change in Gibbs free energy, change in okay, Gibbs free energy Okay, understand? Del G naught is equal to here, okay, standard. This is the standard one. Standard change in Gibbs free energy, R indicates all universal gas quantity temperature. Very important, that is Q. Q which is indicates here reaction quotient. Reaction quotient, very very important. You studied in equilibrium, which indicates the extent of the reaction. At each and every point of the reaction we can calculate reaction quotient. It is given the relation between Gibbs free energy versus reaction quotient. Okay, from that how to do it? Already we studied in thermodynamics, del G is equal to minus NFE cell. Okay, next one, if you consider here at the standard condition, del G naught is equal to minus NF E naught cell. Just you are substituting in that formula. Okay, I can consider this is equation number 1. What will get it? Just you have to observe. This expression is very very important, dear students. Okay, now I can write here. Okay, del G value, dear students, minus NFE cell is equal to, okay, del G naught value minus NF E naught cell plus RT ln Q. RT ln Q. That implies how to write, dears? Okay, now NF is I am taking as a common here. Okay, dividing E cell is equal to, okay, E naught of cell, okay, minus, okay, here I am multiplying with minus also, RT is divided by NF ln Q. Then how to write, dear students, here? Okay, E cell is equal to E naught cell minus, okay, I can take it here, natural logarithm into to the base 10, 2.303 into RT is divided by NF logarithm of Q to the base 10. This is the, okay, one expression we can take it here. E cell is equal to E naught, okay, minus, okay, E naught cell minus 2.303 into R, okay, T divided by NF log Q. Then we can take it here, R is equal to, I can consider 8.314 joule Kelvin inverse mole inverse. Okay, next one, T I can consider 25 degrees Celsius, that is called as here 298 kelvins. F stands for Faraday. F stands for Faraday, that value 96,500 coulombs. N stands for number of electrons change. Number of electrons, okay, change. Okay, change in number of electrons. Q reaction quotient. Then I can, if I write this one, then E cell is equal to E naught cell minus 2.303, R value 8.314, temperature 298, which is divided by N into 96,500, then logarithm of Q to the base 10. If you calculate this entire value, then E cell is equal to E naught cell minus, if you everything multiply here 5790, which we divide here, what will come? 0.0591 is divided to N value I didn't, because I did not consider for any reaction. Okay, N number of electron change, logarithm of Q to the base 10. This is the way we have to write. This is called as a NERNST equation. E cell is equal to E naught cell minus 0.0591 divided by N logarithm of Q to the base 10. Okay, now you can write like this also. Then E cell is equal to E naught cell, E naught of cell at standard condition minus 0.0519 divided by N. Okay, logarithm of, okay, Q how to write, dear students? That time you discuss in chemical equilibrium. Okay, reaction quotient generally which is studied, it is the, okay, the ratio between the product of, okay, concentration of the products to the product of concentration of the reactants. Simply I can write here, concentration of product is divided by concentration of the reactant to the base 10. Okay, this is called as here E naught cell with respect to this one. Understood, dear student? This is the final formula. Okay, this is called as here NERNST equation. Okay, from that, okay, next one, very next expression which is called as here, okay, Gibbs NERNST equation we have to, okay, we have to derive equilibrium constant from the NERNST equation. Okay, equilibrium constant Kc from, okay, NERNST equation, from NERNST equation. These formulas are very important to calculate, dear students. Okay, numerical part. Okay, now if you take it this one, okay, then how to write? First of all, what you have to do it here. For example, if I consider one small reaction Zn plus, this is the standard reaction, dear students. The solid and it is aqueous gives rise to Zn2 plus Cu, it is solid, this is aqueous. Very important, why we are considering this reaction, sir? That means you can take it here. Okay, after some time, okay, after, okay, passes the time, okay, then what will happen? Slowly the already we studied at initial time the reactant concentration of the reactants are very less, okay, sorry, more. At the same time concentration of the product is nil. After some time slowly the concentration of the products increases. That means here the concentration of the Zn2 plus increases, okay. At the same time then what will happen? Okay, the concentration of Cu2 plus ions will be decreasing. At the same time, like this is happening here, okay, the voltage which is reading in the voltmeter, okay, the voltage, okay, of the voltmeter, okay, to be decreasing. So what will happen at particular stage? The concentration of Zn2 plus and as well as concentration of Cu2 plus ions, okay, is, okay, there is no change in concentration. If there is no change in the concentration, then voltage meter reading also will be coming as a constant. Then, okay, then when it is vacuum, so okay, the voltage of the voltmeter will be taken as constant, that is comes under 0. When these two ions are, okay, attained equilibrium, what will happen, dear students? At equilibrium the voltage of the particular, okay, voltmeter, what will happen? It is comes to resting position, that is 0. Then at equilibrium you can consider the standard, okay, sorry, the E naught, the E cell, what is, dear student? The E cell of the reaction becomes 0. Because of that only we have to consider at equilibrium state at the standard electrode potential, the reduction potential of the particular cell becomes 0. So I can write here 0 is equal to E naught cell minus 0.0519 divided by n logarithm of, can I consider this is, okay, product by reactant concentration, can I consider this is Kc to the base 10? Okay, very good. That equalize E naught cell is equal to here 0 at equilibrium. Why E cell is equal to 0? This is the explanation. E cell is equal to 0.0519 divided by n logarithm of Kc to the base 10. Okay, then what we want, dear students? We want Kc value. Then logarithm of Kc to the base 10 is equal to, okay, what will happen? E naught cell into n is divided by 0.0519. Okay, now this is the expression for, okay, logarithm of Kc, okay, equilibrium constant. N value, if we take this reaction, we have to substitute here value 2, because n indicates the number of electrons change, the number of electrons transfer or number of electrons gain or, okay, lose. E naught cell into n divided by 0.0519, okay, 591. This is the expression for logarithm of Kc. Okay, next one more expression is there. Then, okay, we can take it this one, okay, Gibbs free energy. There also we can represent with respect to from NERNST equation, okay, Gibbs free energy we have to calculate from NERNST equation, okay, no others you can take it here. Now, okay, generally Gibbs free energy, how to do it here? How to, already we know, okay, then, okay, already we know del G is equal to minus NF, okay, you can take it here in terms of a standard condition, del G naught is equal to minus NF E naught cell. This is, okay, Gibbs free energy. Then generally how to, okay, write it this one, del G is equal to, del G naught is equal to, what you have to write, dear students? Minus RT ln, okay, you can take it here Kc to the base 10, base 10. Then del G naught is equal to change in Gibbs free energy is equal to here minus, okay, I can take it in, sorry, I can take it in terms of natural, okay, to the base 10 to minus 2.303, okay, R into RT logarithm of Kc to the base 10. This is the way we have to write calculation for, okay, del G naught value. This is the Gibbs free energy is equal to minus 2.303 into okay RT logarithm of Kc is divided Kc to the base 10. Okay, if you calculate this one here, you can take same reaction. Okay, for example, okay, same reaction I am taking example how to do it. Zn plus Cu2 plus, this is aqueous medium, this is solid, gives rise to Zn2 plus aqueous plus Cu, this one. Okay, now standard reduction potential of okay Zn2 plus, simply I am telling here, okay, is correct value minus 0.76 volt. Next one E naught of Cu2 plus 2 Cu, if you take it here, plus 0.34 volt. This is the reduction potential value for zinc and as well as copper. First of all, if you want to calculate the E cell, you need to calculate E naught cell. Then E naught cell is equal to E naught of cathode minus E naught of anode. Already we know this one. Okay, from the here E naught cell is equal to cathode, where it will be reduction copper here plus 0.34 minus of minus here plus 0.76, that is equal to 1.10 volt. This is E naught cell standard reduction potential value for this reaction. Okay, E naught value we got it here. Okay, understood. Then if you want to write it here, then what will happen, dear students? Okay, then E cell is equal to E naught value here 1.10 minus 0.0519 divided by n value here, number of electron transfer here from 0 to plus 2, there are 2 electrons here also 2 by 2. Okay, then logarithm of, okay, you can take it, if you take it here Kc to the base 10 if you want to calculate here. Okay, or Kc value, okay, sorry, then how to do it here, logarithm of, okay, what is the product? Product is comes under concentration of Zn2 plus divided by concentration of Cu2 plus. This is the way we have to write the expression. Okay, this is NERNST equation. Sir, what is the final formula? Then we don't know what is the concentration of Zn2 plus versus Cu2 plus. Now E cell is equal to what, my dear students? 1.10 minus 0.0591 divided by 2 log concentration of product. Which is the concentration of the product? This is the concentration of the product by concentration of the reactant Cu2 plus. This is the way we have to calculate E cell. Okay, dear students, I hope okay everyone understood. This is whatever we so far we discuss. Okay, main, okay, the classification of the electrochemical cell. Electrochemical cell, like it is the interconversion of okay chemical energy which is converted into electrical energy. From there we are having the two cells. One is comes under galvanic or voltaic cell versus electrolytic cell. Okay, just within. In electrolytic cell, what we are doing, dear students, anode we have to represent with positive, whereas cathode represent with negative. Anode oxidation as usual, and cathode okay reduction takes place here. Okay, electrolytic cell, it is only applicable for the non-spontaneous reaction. That means here delta G value becomes positive. But in case of here okay comes under galvanic cell, delta G value becomes negative, that is spontaneous reaction. There anode lone, LOAN, left side oxidation, anode and okay negative. Next, in case of here okay right side RRCP, right side reduction and cathode positive, then that is the different. But in case of electrolytic cell, we don't want to use any type of salt bridge, but in case of galvanic cell we are using salt bridge. Salt bridge already functions, we got it. Next one, how to calculate here reduction potential. Okay, what is the reduction standard we have to consider? That is standard reduction potential for the hydrogen, its value becomes 0.00 volt. From there we done it here. Okay, what is electrochemical series? The arrangement of metals according to increasing order of their standard electrode potential. Okay, the most okay standard electrode potential, most okay greater reducing power. Okay, next one, most positive electrode potential values are having the okay most okay oxidation potential. Next, cell potential calculate, there is the potential difference between two electrodes. Then we calculate it. From there we calculate NERNST equation. This is the very important. Okay, next we can continue for the next video lecture. Thank you, dear students.